Hey everybody, this is Larry. This is me going Q4 of the weekly contest 422 or 442. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. So this one is harder than it seems. It's just that there are a lot of ChatGPT people, it seems like. But I would say this one is more like I want to say some combination of math and intuition and stuff. Honestly, I made a mistake with this one, which is why I end up taking almost 50 minutes and 4 wrong answers. So the wrong answers, actually, I would have gotten it anyway, because it seems like that was... but I also wasn't confident about my final solution until I knew that it was right kind of thing. Then I was like, okay, the proof could make sense. But yeah, so for this video, feel free to fast forward. And I'm not going to go over it in too deeply in detail, but people do ask me how I come up with the solution sometimes, right? And yeah, I'm going to tell you why I did the things I did, because I think it's just more interesting for my videos. Otherwise, you can just, I don't know, read anything else or whatever, right? But for this one, I actually thought that, first of all, the constraints is 10 to the 9 and everything is divided by 4. So I thought that maybe, we have a 2 to the 15 to the 16 situation, or 4 to the 16 or 4 to the 15 is already bigger than 10 to the 9. So I thought so the max number of moves that you can take will just be 16, right? Or 15 or 16, something like that. But small enough that in theory, if you have a 2 to the 16 algorithm, that'll be fine. And my first attempt, I actually incorrectly assumed that you will always, there's a sort of a greediness in that I thought there'd be a parity thing. And what I mean by that is that I thought that if you have two numbers that require the same number of moves, you just pair them down, right? So then they kind of cancel each other out in a way. But it turns out that I was wrong. And the really simple case is actually in this one, right? Because in that case, right, you have two numbers of move 1, or two numbers with with 1 move, one number with 2 moves, right? And so if you kind of pair these two away, then this one will require 2 more moves. So in total, that's 3 moves, right? Because if you get rid of the 2 numbers of 1 move, this one takes 2 moves because it doesn't have any number to pair with, which means that you pair with a 0, just, but you end up doing 3 moves. And then, but the way that I was thinking about it is that, okay, so I thought this was incorrect. But as you can see, even here, the number of required operation is 2, because you pair one of the number 1 with the 2 and then the second one as well, so you only take 2 moves, right? Okay, so that's basically so my mistake was that, because I thought there was this pairing thing, I thought maybe there's a dynamic programming solution, and it turns out that was just really wrong. Because, and the dynamic programming solution, if it was correct, is that, well, if we could pair every move, that means that because we have 16 different numbers, one number with 1 move, 2 moves, 3 moves, and whether we have an extra non-paired one, right? Anyway, like I said, this is not correct, but that's basically what's my logic. And you can watch the live portion if you want to see me solve it. It took like half an hour or so. If you watch the live portion, you'll see it there anyway. But yeah, like I said, it turned out to be wrong. It took me like half an hour to write, maybe a little bit longer, and it took me more time to think about. So how do I solve this? Well, it turns out that if people know the more general version of this, is actually kind of tricky. There is this idea of there's this like really beautiful formula, which I'm not going to go over in this one, but the idea here. But I think the visualization is actually not that bad, so maybe I'll draw it out. So the more standard one, if you do know the standard one, it's going to look something like this, where let's say, why is this so annoying? Where, like if one thing needs 3 moves, I just want to wait. One thing needs 3 moves. Let's say that's height 3. Another thing needs 3 move. Then another thing needs 6 move. And maybe we'll just do them in. All these are already sorted, right? 6 moves. 7 or something like this. You know, something like that. I mean, it's not perfect, right? 8. So something like that, right? And it turns out the idea behind this matching is that you can draw a sort of a median line to it in terms of yeah, because basically the idea is that if you, and I'm not, this is not precisely correct. There are problems where you need this, so you can check those out. But the idea is that, okay, well, if you process 2 numbers, you know that, you can take, this is 7 and 8, so it doesn't really make sense. But here, if you go up to 6, then you have something like this where you take this one and then you move to here, and so forth, and then maybe yeah, and then if you process this here, then you know the number where you can move forward and stuff like that. But the idea there is that it takes time to calculate this out, right? And it's O of n in the number of things that you can remove, which in this case we can have 10 to the 9 number of things to remove, so that's not gonna be fast enough, right? Honestly, partly is because I ran out of time, so I kind of YOLO'd. But the key observation about this one and versus the general one is that, and this isn't a hard proof, but this is what I thought during a virtual contest. Well, one part is, like I said, if this wasn't right, I don't know how to do it. So I was like, okay, let's just give it a YOLO try because I'm running out of time. But the second thing is that, keep in mind, because here we have a range, right? The queries are all a range. And what that means is that, in a way, it's almost like a continuous type of thing, meaning that if meaning if you have numbers that requires X move and you have numbers that require X plus 1 move, or if you have boxes that requires X move and you have boxes that require X plus some K moves, right? It also means that every number, or there at least one number in between where it exists, right? So there's no discontinuous kind of thing. So there's no jumping around. You don't have to do crazy math. And then the other thing is that while pairing is still suboptimal in the final sense, it's still mostly accurate, right? In the sense that if you have a lot of numbers, then if you have a lot of numbers, then a lot of them would just end up getting paired off anyway, right? It is just, And what I mean by that, and another way to think about it though, is that if you think about the way that we pair, what happens if we pair too much, right? So let's say we have this one. If we pair too much, it means that now we have 2 moves where, so let's say we already done these 2 moves, then here it means that we have 2 moves where we select 0, right, as a partner. And so maybe another way to think about this is that we're trying to minimize this instance. And as a result, as a result, then we will always have, as a result, because everything is continuous, you will always at most have 1 0, because you can always pair either a number with X with another X, which is trivial, right? It takes X moves, or X with an X plus 1, right? And that's really the entire problem here. You can actually even, honestly, Yeah, honestly, I think you can actually just reduce it that way. I think I saw a lot of stuff, but you can actually reduce it in that you always, instead of matching exactly, you can always match in two ways, right? You have an x and an x plus one, right? The thing with that is that yeah, because if you have, and I think from this, if you really want to, you can just count the number of odd parodies, and maybe that's a few more moves, but because everything is continuous, because if you look at your range, it's always going to look something like, one number takes x move, x move, x move, and then eventually maybe an x plus one move, x plus one move, dot dot dot, and then x plus two move, right, dot dot dot, right. As a result, you can always just take adjacent ones. I think this is actually a cleaner explanation. I mean, I think the other things are more interesting as well, but that's why I thought the dynamic program would work. But in terms of a correct solution, you can think of this, right? And the only time that this is not great is that when you're forced to, like, by odd evens, maybe this, you have an extra one, and this means that there's an extra one, right? But it's also, as a result, keeping in mind that we're dealing with powers of 4, right? What does that mean? That means that every adjacent gap, that means that every group will have, well, just even number. It's actually a multiple of 4, but also even numbers of items, right? So that means that everything here in the group will have even number of items inside. It may not on the outside, just because, well, we arbitrarily get to cut it, right? But everyone on the inside is even. So that means that, so that means that the only thing that happens is in the gaps, right? Because you're always removing adjacent ones, and as a result, you can always do it. And that means that if this is one gap, there's also one gap here, but that's fine, right? And if you have odd number of numbers, that's also kind of fine. Because basically, if you have 3 numbers, let's say you have 3 numbers of like x, right? Well, in this case, this is a lot of case analysis as a proof, honestly, but you can work out all the details, right? Meaning, if you have 3 numbers, because you cannot have one number, because if you have one number, then you do crazy. But actually, the inputs is such that you have at least 2 numbers, right? Because L cannot be equal to R. So in that case, you just do an if statement, which is fine. But yeah, so you cannot have this. That means that you always have at least 2 or 3, right? If we have 2, this is trivial, like we said. If we have 3, this is also trivial, right? Because we can just do the math, because you can just alternate, almost like if you want to. Like here, let me bring up the drawing again. It's not that bad to alternate, because now if you want to think about, you have 3 boxes of some height, right? And then now it's just thinking about like tightening it in order, like, okay, we're doing 2 at a time, these two, not drawing the scale, these 2, and so forth, right? I mean, this is pretty, I think the visualization is pretty straightforward, and you could work out, that it's just the total area. Oops. So the number of moves is just the total area divided by 2, right? Yeah. And then, and of course, except for the extra 1, which is fine. But yeah, and maybe this is a good way to do like an induction thing, right? Because then now, by induction, we have 4, then you could just pair 2s together, which is fine, right? Of course. And then an extra 1 don't work. And then now you only have to deal with, okay, well, what if we transition to this thing, right? Well, if you do a transition to this thing, here will be x plus 1. If you have 3 things, it's still just the area, right? Because you can kind of do that sneaky thing that we... Oh, actually, I'm blocking it. What I was saying is that, okay, well, now you have this thing, and yeah, maybe, and as a result, you can have all these things, and yeah, and keeping in mind that, okay, let's say this has 1 number left over, then you just kind of always sum all those up as well, right? Because if you have one number left over from here, meaning that if you kind of look at this visualization and there's one number left over, then you can always also combine so all your leftover numbers, as long as you have all these leftover numbers, but all those leftover numbers means that your box is left over, but they're always size 1, right? They're always size 1. That means that you have freedom to do anything, and as a result, then you are able to just put them all together. Hopefully that makes sense. I think that is the proof by almost case analysis. I'll summarize it very quickly, which is that, okay, we're always going to have a range of at least 2 numbers, right? And they're all adjacent to, the range is always going to be x or x plus 1, and you can only have one transition anyway. And then you either group them in pairs of 2s or 3s, right? And because it's a range that is at least 2, then that means that it's just, the way that I would do it is just 2 plus 2 plus 2 plus 2, like groups of 2, 2, 2, 2, 2, and all the way to the last group is going to be either 2 or 3, depending if it's odd or even, right? And if you think of it that way, then now each of these groups will have either 0 left over or 1 left over, right? So each of these groups will have 0 or 1, and if you have 1, then you just match all the 1s together, and it takes 1 move to remove all of them. And then now if you have an extra 1, then you have to do 1 move. So in that way, you only have 1 0 left over. And that's really the idea behind this one, and that's the proof. It took me a long time, and long time to even say, but hopefully that is a good summary, right? And yeah, and that's basically the idea for this one. So going over the code, this code isn't the cleanest, but it's fine, right? So for left R queries, what I do is do this thing called I forget what it's called, but it's just like a prefix something, right? Where to get the numbers between L and R, I just I get all the numbers from 0 to L, and then 0 to R, and then we just do a delta of them, almost like a prefix sum, subtracting out the 0 to L minus 1 inclusive, so you only get L to R, right? And what this function does is just gets me the number of numbers that have X digits in base 4, right? Or you can think of it as the number of moves that it takes for, or how many numbers where A sub X is the number of moves or something. All right, let me just write it out. So yeah, here A sub I is the number of numbers, which is hard to say, that requires I moves to get to 0, right? So that's basically the idea. Yeah, and then so A sub 1 is going to be the number of numbers that requires 1 move, so it's 1, 2, and 3. 4, 5, 6, 7, 8, all the way to 15 is going to be 2, and so forth, right? And this one looks very awkward, but yeah, you can we'll go through it. So we start with 1 digit, and I think of it as base 4, right? So here I count how many numbers have at least yeah, I don't know. I wrote this in a weird way. Honestly, it feels weird now. But it just basically fills this up with this is saying, okay, there's 4 numbers here, and so forth, right? Yeah. Basically, if it takes I, then it takes the min of these 2 numbers, and basically you'll have leftover, right? And then I kind of just do a subtract to get the difference, because here current will go from 1 to 4 to 16 powers of 4, right? 64 ... So then this array will just be like, okay, well, if X, at some point, X will be the limiting number, and then this is just the delta on top of that. And here I just get rid of the number 0 because because I counted as having 0 digit, but if that 0 digit is already done for this problem, which is I set it to 0. Don't I think it doesn't matter because I end up subtracting them anyway. But I don't know. I thought it made sense to me at the time. But yeah. And then now this is just the cost. The reason why I have cost 2 is because I cost 1 was the way I did it dynamic programming. I was wrong. But yeah. And this was a bit mask which I had left over from dynamic programming actually. But yeah. Here, so then now we know that this is the number of numbers that requires I move. So now we're just calculating the area, right? And the way that we do about it, right, is that all the areas will have either 1 left. You just pair them up. You have either 1 left over or 0 left over, and then you kind of just like, if you kind of put them on top of each other, even with the 1s left over and 0s left over, then it's just the area of everything, right? And that's basically how I kind of did this. And again, we pair them up. In terms of the area, we pair them everything up, and then we have 1 left over. So the only time where this is not true is if we have one really long, like if we have 1 box and that's it, then this doesn't hold. But that's also honestly just an if statement. So I don't know why they didn't do it. Maybe for once Leetcode is trying to be nice or something. That was surprising, honestly. But yeah, and that's it. And then for each query, obviously we sum it up. No big deal, right? And that's it. Everything is, log based 4, right, for each number. But that's linear in the size of the input. So everything is relatively linear, right? And that is it. Yeah. And this is the entire part. That's all I have with this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live during the contest next. These things live. And just try and see let's see how my ranking is so far. Probably could have done that one a little bit faster. I had a couple of typos that was pretty bad. 14 seconds. Come on, Leetcode. You could do better than that. Okay. Wow, people got in 2 minutes. I guess, with the power of ChatGPT, anything can happen. All right, anyway, let's see if I can solve Q4 without the power of ChatGPT. Okay, let's see. Queries of I, you have left, right, queries of I get some drink. Find the array of integer nums. Okay, what does that mean? One operation, you can swap or select 2 numbers A and B. What does that mean? You can make them smaller. Huh? What is a query? What does that mean? Query. Okay. Oh, I'm just misreading this. Oh, I'm reading this dumb. Okay. It's not a query though. It's such a weird thing to call it that, but maybe not. Maybe it's fine. Okay, so you have 1 to 2, and then here's 2 to 4. Okay. And then you have in one operation you can select 2 numbers and then replace them. And we have a lot of them, so you have to be able to do them relatively quickly. And the numbers are nuts, so you don't have to worry about it. What is the strategy here? I mean, there really is not that much strategy, right? It's just you have the number of users. And then there's the same problem that we always have done with the counting, right? Oh, but it's contiguous. Maybe the contiguous part is maybe interesting. Huh. It's just like a way. It's not a very algorithmic. It's a very problem-solving problem, but it's not very algorithmic. Because it's just doing the math. Maybe. I mean, there's maybe some edge cases, but it's not an interesting problem per se, if you ask me. But okay, 1,000 people got this. I mean, yeah, people are better at math than I am, so I'm not that surprised. But okay, so what does divided by 4 mean? Is it just log base 4? I don't get it. I'm trying to think what the idea is. Okay, so here this 111. So it is just log base 4 round up or something, right? You have 4, it takes 1 move. You have 5, it takes 2 moves. And then yes, so 16 it takes 2 moves. And oh no, 16 is 3 moves, right? So okay, but so every power of 4. I mean, but you can't really but you can find a distribution, right? So the distribution is just log based 4. What does log based 4 mean? Log based 4 means that 10 to the 9 is 15, right? 4 to the 15. So 4 to the 15. That means we can maybe brute force on 15. You can do some because none of that matters. It's just it's a bitmask DP, isn't it? Huh. It's a very crazily disguised bitmask DP, it sounds like. And then you just kind of, it's just a parody of the numbers of things. Okay, fine. Because there's no choice other than matching up the odd parody stuff, right? Can it be odd? Well, I guess it can be odd in the sense that you just choose one that's already 0. I guess it probably even mentions it in this one. Actually, no, it doesn't. But that's odd that they don't have. That's odd that they don't have one. But okay, so just bitmask DP. Is that it on 15? Okay. Yeah, and that bitmask is actually very awkward because you can actually globalize it, I think. Right. And here, if bitmask is 0 to 0, so that means you're done. So you 0 move. Otherwise, okay. So what are the states mean, right? So you have a 15. You have one odd even parity. So you remove 115. Is it 15 squared times 2? I guess that should be fast enough. Still awkward, but fast enough, right? Can I? I mean, you probably could optimize this a little bit, but I think I'm just writing it the dumb way first. You also want to. Yeah, okay. I mean, maybe that's fine. Now you can always take one from 0, so that doesn't matter. And the number of counts on 0 doesn't matter, so we have to be careful about that. So here, something like, we have to get rid of the zeros, so how do I write that in one? I guess maybe not. something like that maybe. Right, I think that's fine. It's a very ridiculous function actually, but okay, fine. Right, so then now it is just you move one over if that's the case. Does it have to exist? I guess so. We should. I think we should. I could be wrong, maybe actually, but because you can always just take one. Okay, fine. Okay, so now we're trying to minimize, right? So it doesn't have to be actually be infinity, but I think infinity is fine too. It doesn't even have to be that big. Keep it an int for slight performance benefit. So it's best. Or now we want to shift. We want to shift. We want to flip. Okay, so we flip those two, and then we also flip I mean, it's technically true, but I think I have to be careful about this. The states are fine. But it is more than one. If it's more than one, can you always pair them together? Do you want to ever pair them together? Maybe that doesn't make sense. I don't know. Okay, let's try the thing where we just do one first. Okay. What would that look like? Okay, so we flip one and one does 0 once, so it doesn't do anything. But then now we have to keep track of. Because then it's, yeah, you don't want to delete those. If they match up, then they can eliminate it. But is that always ideal? I guess that's always ideal, but it's still very awkward to write. Yeah, that's fine. Awkward is fine. We just need to do it with part. This is only a 6-pointer. That's actually kind of. Maybe I'm doing this in a crazy man's way though, but maybe that's fine. I don't know. Okay, yeah, fine. So if okay, so if there was a one previous, then we don't feel great about this one, but that's fine. So it's this plus it's one move and then I times 2 moves or something, right? Otherwise, we can just keep it. In the base case, we can always just get rid of it all the way. I think no, it's not I over 2. It is I moves Oh, I minus 1. Yeah, okay, so wait. Oh yeah, I guess it doesn't matter where the, okay, fine. I guess in this case it doesn't matter the way that I'm doing it, because you just get, but do I want to do it that way? Does it even make sense? No, because if it exists, then you pair it all the way down. But the states are different, right? I think this is fine. This is actually, those are two different moves. Because here you just repeatedly get 1 and 0. But that's a shortcut on a state. Is that shortcut on going to bite me? I think it might actually. So, okay, so in this case, you actually also want, but it's still the same cost. So that's fine. Okay. And then now, yeah, we do need this, but it's very awkward. Okay, so we do. But now there are two of the I minus 1 and J minus 1s. Okay, whatever, let's just do. Right. I mean, I think this part is fine. I think this part is not going to change, but then if it exists, then we have to okay, so cost is going to be equal to 1 if this is PM and cost we add by I minus 1, just because then we'll pair them up. I don't know if this is right. It feels very awkward. And also, like, if I'm wrong, it's very not easily debuggable. I have to trace so much stuff. But okay, so those are the, I think those are the things on the choices, and that assumes that we match them up. Okay, and then now this is annoying. I feel like it's very easy off by 1 here. Yeah, okay. I mean, these are just normal things, so we get R minus 1. So we have a 15 element, right? Okay, right. And now we just answer that append. So okay, so how do I do this? And then now it's for I in range of 15, I guess. Yeah, should put in a constant really, but unless I'm really wrong. If I'm really wrong, I'm really sad anyway. There are a lot of built-in assumptions here. Okay, so a sub I divided by 2. So cost, we add this times I, and then a sub I mod 2 or n1. So this okay, fine. If this is greater than 0, then we shift I and then we just go PM, right? Something like that. And then now we have to write that function as well. Okay. Okay, so one move is going to be 4, right? So yeah, so how do I do this? I guess it should be for loop. Okay, so current is 0 to 1, maybe, right? So we don't count 0, right? Okay. Maybe start at 1. Then okay. If x is does 1 have 0? 1 has 1 move, Larry. Okay, fine. So we should start at so the 4 it's off by 1, but I think that's fine. We just have to remove 0. Remember to remove 0. So okay, so a of 1, 1. Okay. So then if x is greater than or equal to 4, no, it has to be exact. Maybe, I don't know actually. Okay, so if x is 4, then if x is 4, then there are 4 numbers. I think, yeah, okay. Then x minus current. Actually, a sub I should you go to max of, not max, is it? No, min of the current, or x. No, because it's delta. It's not just 4. It's the delta between 4 and 12. Why am I so bad at this? It's fine. You could do a prefix subtraction later, Larry. Yeah. I can't believe this part is the part I'm struggling with. I mean, I could believe it actually. I'm pretty bad at stuff. Okay, so okay, so then now 16 minus 1. Yeah, okay, then it's just yeah. Wait, no, this already does this, right? But this thing is wrong, so I have to do it like this, and then now for something like that. And, this is gonna be nuts. So. Oh, I have to return the sum, right? Not just, okay. That's actually kind of silly or funny. Which also makes, I don't know if it makes sense, but okay. I'm just going to keep it this way for a little bit. Oops. So that in case I need to debug, but I need to remember to remove it. Now, this is actually right, but I don't know if I'm just lucky or not. So we can actually, they only have, I could actually, well, I could print it out. One and 2 and 4. I mean, I guess that's fine. I don't know. I mean, I feel like I should test this one a little bit more because this is just too magical. This is I'm so bad that it's just hard for me to believe that I can get it on the first try anymore. There's just so many places to get it wrong. But yeah, so this is and no, that's right. 4 and 16. So 3 and 12, is that right? I think that's right. No, I mean, no, that's definitely wrong in the sense that you're off by 1, because the sum of these should definitely not. Okay, so this thing is maybe a little bit of a hack. Okay, 4 and 12, that's actually right, but so 0, 1, 2, 3. So 16 has 16 numbers. Okay, 4 has 4 numbers, so we're discounting 1, right? So what am I doing here? Well, I'm counting 0. I'm using 0 index, so I need to increment by 1. Okay, maybe. And then now we take out the 0 index the way that we did it before. So I think now we're fine. I think technically this should start at 1, is why this is a little bit awkward. Technically 0 is not a 1-digit thing, even though it may look that way. And as a result, kind of write it this way. Okay, that's fine. And then now we take out the 0-digit 0. Okay. Yeah, okay, fine. Right. And then here, maybe I'm testing, is this good enough for me to do? I don't know, 1, 2, 2, 2, 3, 4 is right. I mean, okay. I don't know about this one either, but yeah, okay. Let's try the worst case real quick. I don't think it should change anything, but also let's get rid of the debugging things, especially the low stuff. Times, well, how is it? 10. Huh? What am I doing wrong? Is that wrong? 2 maybe. I don't know. Maybe today I just don't know how to program. But okay, that's, I mean, it's not fast, but it's fast enough maybe. I don't know if I could get that much faster. So let's YOLO go. No wrong answer yet. Maybe? Okay. Okay, well, jinx myself. Wait. Did isn't that the input? Did I mess this up? Oh, I changed. What did I change? Because I had it was the right answer, and then I changed something, and now this gives me the wrong answer. Huh. That is funny. Because I checked it, but then after I ran the running speed test, then I guess the answer changed, and then it's just wrong because I wouldn't have submitted, obviously. It's very sad, actually. But okay. Am I still off by 1 here? Okay, you're trying to solve for 2. Okay, fine. The cost is 1. Is that true? Yes. Cost is 3. This one is not so true. Is it? One, 2. No, that's 1, 2. No, that's not 3. Why would it get 3? Why? That doesn't make sense, actually. How does that get 3? I mean, something here is wrong, I suppose. Okay. Maybe I just had 2 bad mistakes cancel each other out, I suppose. Well, that's still pretty bad. That, I mean, what a waste of 5-minute wrong answer. Okay, I mean, that's fine. Not great, but fine. Let's just do a print real quick. So this should be 4 returns 2, which is for this one, I think. But okay, something is weird. So this returns 3 because that's one element, right? Do I call that? Oh, bit mask. Why does it not? Okay, so it calls it for 4. Is that a 4? Yeah, that is a 4. Did I mess this up? Oh, I did. Okay. I actually forgot about I actually totally did forget about it. So we want to remove it. Otherwise, we still want to remove it. But the cost is plus. Yeah, okay. So this is the case. No, okay. So it doesn't exist. Then we want to add to it, which is different, I suppose. This is very awkward to write though. I mean, okay. The reason why I write it this way is so that because I'm subject to change, but that didn't do it, huh? I mean, that's definitely maybe wrong. Bit mask 4. Why is 4 giving me a 3? No, 4 gives me a 2, right? I had this. Oh wait, no, is it a 2 or 3, Larry? One move gets rid of these 2, and then it's just 1, 2. So there is a 3. Wait, is it a 3? Am I thinking of it dumbly? I mean, maybe. Okay, here. So you have a 1, 1, 2, right? So you have a. Why am I getting 3? Oh, okay. So you remove the pairs. That's 1. Oh, maybe this doesn't work then, huh? Because okay, yeah, okay. So this is wrong because I assume that you always want to pair up. Which is apparently not true. Yeah, that's not true, is it? Oh, but then you have those 2, and that is clearly suboptimal. Huh. Wow, I spent a long time to not. How much time do I have left? Oh, I guess this is not accurate. Is there anything that has tells me? Oh, 26 minutes. Huh, I may not get anything. For this one. How do we think it? I made a really wrong reduction, huh? Wasted a lot of time on that reduction. Okay, let me think. Is there a more dumb move? I mean, a lot of people solved this one, so I don't think it's supposed to be a hard one. Okay, that's a really bad reduction. How does? Okay, so it's this part. I feel like it's just a DP part, maybe. So this is definitely okay. Huh? I can't tell if this is just an edge case on this though, because for most numbers you want to pare them down. The reason why you never want to pare these down is well, you only have 3 of these, right? So maybe we can abuse that. I think it's still true. Well, no, it's the thing where you do, but a lot of them are paired up. So a lot of it is not that possible, but you do. Man, I'm thinking about this far more wrong with the dynamic programming, huh? Alright. Restarting during a problem is such one of the hardest things. So I have to maybe restart. I don't think it's just about doing that. Is it an algo? Is it greedy? Maybe it's just greedy. Maybe the DP is just silly. Basically, you want to. Okay, so the number of fixed moves are fixed. So you just want to try to avoid using zeros as much as possible, right? Just like a maximum bipartite thing, except for it should be much more straightforward. Hmm. And the reason why pairing doesn't work is because I force it all the other numbers to the last number to do it. There should always only be one number where that is not true, so maybe we could brute force it. What is it? 100,000? So you wouldn't be at a thing, it's kind of slow though. And this has the same issue with this one. So the thing is that when you add up with one number, that's the problem. Because that number, okay, so you can't do it from the min up. I think that's the thing. And pairing only works on bigger numbers, so only have 15 moves. So that means that, what does that mean? We only have 15 moves. That means that your answer will always be at most 15 off. So we have to adjust for the pairing. That's not great. 19 minutes left. The DP is fine, but the setup to it is not actually. Every time you pair, I mean, I think as long as you pair a number with a bigger number is fine. Until all numbers are the same. That doesn't feel like an easy way to do it though. Especially 100,000 queries. Because even 100 is probably too slow. So there's something dumber than that. I mean, this is kind of nice, but it's just not right. We have to reduce it a little bit. How do I reduce it a little bit? Is it only wrong for? No, the cases definitely you can do on the boundary, like 14, 15, 16 or something. So then now you have 2, 1, and then now you move it in. So how do I fix that? So the one number state is the tricky part. Number left, because then you could borrow from the future. That's how do I do the borrow from the future? Huh. Okay, so the min number of, maybe I could think about it the other way. So min number of moves is just the sum of this matrix kind of thing, except for am I just overthinking this? Maybe. Let's see, right? So, okay. I mean, we're also getting up to running up low on time, so I guess we have to think about this. Okay, so here added by a sub I times I, right? Because that's just the number of moves and the count. What does that look like? 6 and 8. Oh, I have to remember to divide it by 2. Is that enough? Yeah, that'd be funny if that's it. Actually. Alright, I mean, we don't have that much time. I'm 15 minutes. Maybe it's worth buying a long answer on here. So this does have one number left. So I think I just messed up here. Okay, let's YOLO try again. I should have known that one though. I don't know if this is right, but this one I should have known. Okay. Oh, it's each query. Okay. I mean, now I'm just like doing YOLO things. But I should have known this one too. Maybe that's why people got so fast. People are just not dumb like I am. Let's get rid of this real quick. I can't really prove this, but maybe I can. I don't know. Seems like it's still wrong. Yeah, this is off by a lot. Wow. How is that off by that much? Actually. That's actually... Okay, then this is definitely not right then. I thought maybe we can work something out, but this is just off by a lot. So it's not a mod 1 situation. Why? Why not? How can it be off by that much? Because one number should be off by... I don't get it, actually. Let's see. What would be the difference here? Just for science. I mean, my numbers are very similar, so maybe I'm just thinking of... Am I just not understanding this problem correctly? It's possible. Is this right? I don't know. It's probably right? Well, this number having zeros is probably the reason why this is wrong. Why do I have to... Okay, maybe we could debug that. Am I just wrong on the... okay, it's a good thing we have. Does that fix it a little bit? Does it fix it to the right answer? It does. So I'm just dumb on the 17. Okay, that's fine. Is that the right answer actually? Okay, so I'm just dumb on that one. Okay. I mean, I guess I complicated this thing way more than I thought. Yeah, I mean, okay. It wasn't that bad. But all this DP for no reason. Alright, let's get rid of it. I was very wrong on this one. And honestly, the reason how I got this one is because it is a classic situation of, if this is not true, I don't know how to do it. Like it's a YOLO greedy-ish. It's not even greedy, but I think, I mean, I can. I feel like I have a proof on this one, but it's just like it's not a tight proof. I like, there is some like proof around like it being contiguous, which is why this works, because there's no jumping, but it's such a hard thing to prove. Though I did do math. Why is, oh no, why is 15 not, oh wait, no, why is 2 to the 15 not enough? Huh, why did I have to, I mean, that was a silly one wrong answer. Oh, let me also, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these problems, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.